The next method is separating funnel. Now, a mixture consisting of two immiscible liquids. Immiscible means the liquids which do not mix with each other. They can also be separated by using a separating funnel. Now, let us understand this through an activity. The aim of the activity is to separate a mixture of mustard oil and water by using a separating funnel. Because the mixture of oil and water, it is immiscible, that means they do not mix with each other. The materials required for this activity are mixture of mustard oil and water, a separating funnel, an iron stand, and two beakers. Now the procedure is to pour the mixture containing mustard oil and water into separating funnel. Allow it to stand for some time. Note your observations. Now place a beaker below the separating funnel as it is shown in figure and open the stopcock. Allow the water to flow through it. When all water flows through it, close the stopcock. So we can see that this is the separating funnel which is used to separate the two immiscible liquids. We take the mixture of mustard oil and water and we allow it to stand it for some time. Now after that, both the liquids will get separated as it is shown in the figure on the basis of densities. Now due to this, when we open the stopcock, all the water will come down into this beaker and it will get separated from the mustard oil. Now the observation is that mustard oil and water, they form two separate layers. Water forms the lower layer and mustard oil forms the upper layer. On opening the stopcock, water flows through it and it gets collected in the beaker, and mustard oil will remain in the separating funnel, which can be collected in the separate beaker. So we have separated both mustard oil and water. Now the conclusion of this activity is that a mixture of mustard oil and water can be separated by using a separating funnel. Now the next method is sublimation. Some solids, they change into gases directly without changing into a liquid on heating, and from a gaseous state to a solid state without changing into liquid on cooling. This process of changing a solid directly into gaseous state on heating and from gaseous state to solid on cooling, this process is known as sublimation. So if we take a solid and we heat it, if it will form directly a gas, this is also known as sublimation. And if we cool a gas and it forms solid directly without changing into liquid, this process is also known as sublimation. Now ammonium chloride, camphor, naphthalene and iodine, they are some solids that sublime on heating. That means that these solids can directly change into gas on heating. If a mixture contains a solid that can sublime as one of its components, we can use sublimation as the method of separating the components of this mixture. Now let us understand this with the help of an activity. Now let us read about the activity. The aim of this activity is to separate the mixture of ammonium chloride, which is written as NH4Cl, and common salt, which is NaCl, to be demonstrated by the teacher. Now the materials required are ammonium chloride, common salt, a china dish, a burner, a funnel and a cotton plug. Now let us read about the procedure. Mix the ammonium chloride and common salt in a china dish. Heat the mixture. When you see the vapors rising, immediately invert a funnel plugged with cotton at its end over the china dish. Now we take the mixture of ammonium chloride and common salt in the china dish and we heat the mixture. Now after heating the mixture, when we see the vapors are rising, immediately put the inverted funnel which has the cotton plug over its end. Now the observation of this activity is that on heating ammonium chloride, since it is a sublimable substance, that means it is a solid substance and it will directly change into gas. It changes directly into vapor, that is, it sublimes on heating. When the vapors come in contact with the glass funnel, they condense on its inner side. So when these ammonium chloride will sublimate, it will form vapors. So when the ammonium chloride vapors will come on the glass funnel, they will condense on its inner side. And since common salt does not sublime on heating, it remains in the china dish. So we can see that the china dish So the common salt is not a sublimable substance, so it will remain in the china dish. The conclusion of this activity is that the mixture of ammonium chloride and common salt can be separated by sublimation, because even if one substance is sublimable, we can separate both of the substance. I hope you understood this topic well. Thank you.